Alright, welcome back. We'll continue from where we left off last time. Last time we generated these certificates for use by our Jetty server. And so at this point we'll go ahead and continue our server implementation. So we already started an HTTP configuration or an HTTPS configuration. We set the secure scheme. Next thing we'll set is the secure port. We'll hard code this at 8443 for now, and we'll come back and configure this later. Another thing we'll set is we'll add a customizer for the secure request customizer. This is what does the SSL, TLS handshaking as part of the secure connection that we're establishing. Next thing we want is an HTTP connection factory. And I'll actually call this an HTTPS connection factory, since we're going to pass in our HTTPS configuration here. And the next thing we want is an SSL connection or context factory. And we actually want the server, so there's a server one and there's a client one. We actually want the server one. Since we're running a server here. And let's see, what do we want to set? We're going to set all these Keystore parameters as well as this trust all true. So let's start with the Keystore path. So this path is when we run this server locally, we're basically running it from the tutorial API directory. So the path is going to be basically all the way down to our P12 here. So it looks like it's going to be tutorial API server source main resources certs tutorial API.P12. The password is change it. That's what we specified in our script here when we generated them. Somewhere in here, where is it? Yeah, here we go. Password, change it. We need the type, which is PKCS12. Since we have a P12 file, that's, P12 is short for PKCS12. And we also need the key manager password, which is also change it. So basically when we created our P12 and added our key into it, it gave, we only specified one password here, but basically what it did was use this password for the Keystore itself in the P12 file, and then within that file, the key that we inserted, the tutorial API.private key, also was given this change it password. So we have to specify it twice, once for the Keystore and then once for the key within the Keystore. And in these Keystores, you can have multiple keys as well. But we don't, we only have one in ours. All right, now that we have our context factory, we need an SSL connection factory. And we're gonna pass in our SSL context factory. We also need to pass in the next protocol. So SSL basically is the first protocol to get secure connection, and then after that we need an HTTP protocol. So we'll start with 1.1, and we'll go ahead and import this from HTTP version. So we could use HTTP 2, but it's there's more setup than what we have here. We may come back to this in the future, but typically for REST APIs, it's not that necessary. There is there's definitely some performance improvements with using HTTP 2, but I'm not gonna set that up at this point. We'll likely come back to that in the future and add those additional configurations to get HTTP 2 up and running. For now, though, we'll just leave it at 1.1. All right, next we need a server. So we'll create an instance of the Jetty server class here. We need a server connector. Actually, I'll call this HTTPS connector since it's hosting our HTTPS configuration and SSL stuff that we've already set up. So new server connector, we need to pass in a server, we need our SSL connection factory, and we also need our HTTPS connection factory. And now we need to do a little bit of setup here. There are a couple of sets that we can set. One is the port, and so we'll actually, we have a port defined here, so we'll actually reuse that same port like so, and there is a name on here as well. I suspect we don't have to set this, but I'll go ahead and set it anyway. This is our secure connector. Next, we'll update our server to add the connector. And the last thing we'll do is we need to start the server, and we need to join the server. So start effectively brings the process online, and then join basically binds to it. Now both of these join throws an interrupted exception, and start throws just a plain exception. So we'll go ahead and catch exception here. I'll just rethrow it as a runtime exception. And this will cause, of course, our server. If our server doesn't start up, then this will cause it to crash, which is what we want. No need to handle it in any more complicated way than this. In fact, we could just add throws exception up here, and then get rid of this stuff down here. All right. Now, one thing to note is that when we join here, we're not going to ever get past this line. So this code is going to block the main thread until the server either dies or gets killed. So there's no way to get past this line effectively in code. So let's go ahead and run this and see what happens. All right, so we got our hello world log from the very top. We actually don't need that anymore, so I'm going to delete that. And then we got a few server lines in here, and we're still running. And it looks like Jetty's up and running. It's bound to 0000, which means all interfaces. It is using HTTP 1.1 like we specified, and it does have SSL configured, and it's on port 8443. So I should be able to use curl. I'm going to use -vvv to get very verbose output, and curl localhost 443 or 8443. Now, what this output means, so first of all, it's attempting to connect over IPv6, which it is successful at with doing that. ALPN is the application layer protocol stuff, so that's how HTTP2 is implemented, and we didn't add any kind of ALPN configuration or HTTP2 configuration. So curl offers to use HTTP2, and it's effectively declined because we don't have any of that set up. So it ends up falling back basically to HTTP1. After that, it starts SSL handshaking with TLS. So you can see these TLS, in and out client server comms, and we ended up with an alert saying unknown certificate authority, and that resulted in this certificate problem, unable to get local issuer certificate. So what this is saying is that curl made the request, got a response back from the Jetty server, and curl didn't know anything about the certificate authority that signed the certificate provided by Jetty. So there's a few ways to fix this. One of them, if I man curl real quick, there's a -k option, which is also -- insecure. So I see it mentioned here, but It's just a reference. Let's keep going down. Okay, here we go. So we've got -K, which is the same as --insecure. So I'm not going to read all this, but effectively it means, if we pass this in, curl will ignore server certificate issues, and we'll let this through. So I'll go ahead and do that just to demonstrate that. So I just add this -K. Okay, so we see the same initial output. We see more handshaking things, and we end up getting a successful TLS handshake. So it decided on TLS version 1.2 with some elliptic curve, Diffie-Hellman, key exchange with RSA and AES, some encryption protocol. We ended up seeing this subject in the certificate sent to us from the server, right? So it's tutorialapi.com in the CN, and that's exactly what we created over here, right? So we can see that same information here in the server cert. The next thing was this warning message, right? So we added -K for insecure mode. It's still complaining about it, but it says continuing anyway, so it's still a problem. But curl has decided to continue anyway, since we told it that we're okay with insecure mode. These next lines, you can see the arrow pointing to the right. That's curl sending this information. So an initial HTTP request followed by 3 request headers, and then these arrows to the left begin the server's response. So this is the response status line 404 not found, which makes sense because we haven't configured our server at all to actually return anything. But it is up and running and listening. We've got our handlers in place with SSL. So it is accepting requests and just returning not found basically for everything. It also sent back these 4 response headers. So one is cache control, which makes sense. We might tune this in the future. Currently it's must revalidate, which means there's effectively no caching at all. The next is the content type. So it sent back text HTML, and we can see the HTML from the response in the body here. And once we get up and running and actual send real content back, that's not auto-generated, right? This is a Jetty auto-generated response powered by Jetty, and then a Jetty version, and then some request information. So this is like the default error page basically from Jetty. And once we're up and running and we're sending real data back, then we won't see this any longer. Content length. Now we did get this server line. Typically, I like turning this off. What we don't need to do is tell people who are requesting information from our server what kind of server we're running. A little bit of maybe security through obscurity, a little bit, but we can quickly and easily turn that off by coming up here to HTTPS configuration and saying set, probably send server version, set that to false, and I suspect that will turn this off, and we'll test that here in a second. The rest of this is response body and then connection closed. So this request worked just fine. It did what we expected. We didn't get anything useful back because we're not serving any real files or anything, but it did work. Now, instead of this -K, we can tell curl what certificate authority we're willing to accept by passing in a CA certificate. So tutorial, I don't know why it's not letting me tab complete this, but tutorial API server source name resources certs with ca.crt, which I can see it over here. Hit enter. So we don't see that warning anymore about continuing anyway. So so SSL certificate verify okay. So this time curl didn't complain about the certificate authority that signed the server's certificate, which is this one. So everything matched okay. It also checked the subject alternative names in the certificate. We made our request to localhost. localhost is in the list of subject alternative names in the certificate, right? Which we put that info in our ext, our extension file. So because we have localhost in here, then this response was valid. It recognized that the host was okay during the host validation. And everything else is pretty much the same. The same headers went in, the same response came back, and the same body came back. Now, if I go ahead and restart this, now that I set this, this is the wrong one. I need to do send server version, set that one to false. Let me restart this one more time. And then come over here, do this curl again. I'm actually going to get rid of the VVV, and I'll just add dash I, so that we, and dash S. I means include headers in the response headers. S means be quiet about it. I don't know why it's S instead of Q or something, but S basically prevents like some of that additional output. All right, so it's basically the same information, but we no longer see our server response header. So by setting that flag to false, we turned it off successfully. Everything else is the same, of course. So this is looking pretty good. We're up and running now, and we'll take a break here. The next step is to actually figure out how to get Jetty to provide access to some real content. Like right now, we're not actually hosting anything. Before I do that, I'll go ahead and get status here. All we've changed is our one server file, so I'll add that. So update server to run Jetty. All right, and that's it for this one. I'll see you guys next time.